Hey everybody, and welcome back to the channel. In this video we're going to be doing some unboxing, as I have received a couple of packages here almost a year ago, but I just didn't have time to go through them. But that has changed now. So let's open up the box and see what we have inside and how we can use it on the channel here. And inside we have another box from AsusStor, which were kind enough to send this over to me for review and see how we could put it into good use. And see how this AsusStor 4 Gen 2 device could be used in a retro setting. So this isn't going to be your typical NAS review video. There are lots of videos out there that already cover the AsusStor 4 Gen 2. I highly recommend you check it out. But this video in particular is going to be talking about using this device with retro computers and what you need to pay attention to in order to roll this device out in a retro computing or a retro network setting, because obviously we're going to be combining the new with the old in this video, so that definitely has some security implications that we need to be aware of. But all in all, I think it's going to be a very interesting journey to see how we can set up these old computers running old operating systems like MS-DOS or Microsoft Windows and getting them to work with this NAS device. Because this definitely isn't your average use case for these devices, but I do think that they can bring enormous value to the retro computing experience. Especially if you're like me and you have a bunch of computers sitting at your desk that want to exchange software and you're sick and tired of fiddling around with floppy disks, and you're in need of a solution that will allow you to easily exchange files across all of these different platforms, ranging from very old MS-DOS computers to Windows 95 machines, all the way up to Windows 98 and perhaps also even Windows XP. So yeah, I think this will really be an interesting video because it will cover a lot of stuff as we will be installing very old operating systems like MS-DOS to see what kind of network capabilities they have and how they will interact with the NAS device. We will also take a look at Windows for Workgroups 3.11 just to see how the user experience was back in the day to do file sharing. And we'll really get our hands dirty by looking at some low-level log files from the SMB server on the NAS device, just to see how these different clients interact with it and how we need to configure everything to get everything working. But first, let's take at the NAS device itself, and thanks again to AsusStor for sending this to me for me to review. It's a really slick device here with 4 drive bays, making it possible to really extend your storage space for your computers. Really like the finish of the device. We've also got some accessories in the box here. We've got the power cable, the power adapter. We've got some networking cables here and some screws to hold the hard drives in place and a quick installation guide. There's a nice little LED display on the device, which I'm going to be covering. We also have the manual here explaining you how to set up the device, which involves nothing more than just inserting the drives into the drive bays and powering on the device. So yeah, pretty straightforward stuff. And speaking of hard drives, let's see what we have in the 2 additional packages here, because I'm assuming there will be some hard drives in here, and indeed I already see the green Seagate logo, 4 hard drives included. So what we have here are 4 Seagate Iron Wolf NAS hard drives, so specifically made for NAS devices, 6 TB each, 3.5-inch SATA 3. So that would make up like 18 terabytes of usable disk space in a RAID 5 configuration. So slotting them in is fairly easy. We have 4 drive bays on the NAS. There are screws available here for both 3.5-inch drives as well as 2.5-inch drives. So obviously we're going to be using the 3.5 layout. So yeah, let's take the drive bays out and slot in some hard drives. Now on the back of the machine, we have 2 Ethernet ports. We have a USB 3 connection. We have the power connector. We also have an HDMI connector, meaning that we can attach this to a monitor straight away. We have the fan here for some cooling. And so let's plug in our network cable. add some power, and start the machine. So we are immediately greeted with this beautiful LED display on the front of the device indicating that it is starting up. I really like the fact that we have this LED display, making it very easy to configure the device, as I will show you later. We can hear the device booting up, we can hear the hard drives spinning, and using these buttons here on the front panel, we can kind of go through this menu, which will give us all kinds of options on the LED panel, making it very easy to see what's going on, to configure the device and get an actual view of the status. Now, as it is booting, it's obviously setting up the various disks which have been installed on the device, so it will take a minute before everything is usable. We get feedback on the LED display regarding networking information. So if the device has received an IP address from a DHCP server, it will give us a notification here on the LED display, which is pretty nice. So yeah, time to log in for the first time, and we're going to be logging in as an admin account with the admin as a password, which is the default password, something that we need to change right away, obviously. And we are immediately greeted with this important announcement. Now, as you may or may not know, a lot of people have fallen victim to these ransomware attacks that have plagued all of the major NAS vendors, including AsusStor, QNAP, and Synology. And the scenario is always the same, that attackers gain access to the NAS device, start encrypting all of the files, and force you to pay up in Bitcoin in order to get a decryption key, giving you access to your files again. Now, in the majority of the cases, these attacks are caused by improper security set on the NAS device by the user, exposing it on the internet by forwarding ports and using services which are not properly secured. So it's extremely important to follow all the security guidelines that AsusStor outlines here, like changing default passwords, changing ports, not using services that you don't need, making regular backups, making sure that your AsusStor NAS is up to date. And especially in this particular retro computing setup where we are going to be using less secure protocols, it's even more important that you keep your NAS safely behind your internet router or firewall and don't expose any ports onto the internet that might lead an attacker into your NAS device. And as you can see here, in a matter of minutes after the first login, I am prompted to install a new ADM update from AsusStor, which I am definitely going to do. They do a great job of updating their ADM versions, giving out security guidelines, and also getting a clear changelog of what is in every release. So I'm going to be installing this one just to make sure that I am up to date. What will happen here, it will download the firmware from AsusStor, it will install it onto the system, update the system, and then perform a restart of the system. Now, after the software update, the NAS device will restart and you will get access to the web console again. Now, one of the first things that we're going to be doing as we're logging in with the admin account and the default admin password is to go into this access control here, go into local users and change our admin password. I'm sure that there are lots of people that don't bother with this, that even put their NAS device on the internet with the default admin password, and that's basically just asking for trouble. So it's a small effort to change the admin password, so that's what we're going to be doing here. But we're not going to stop there, because as you can see, we have the admin account, we have a disabled guest account, which is also considered a good practice. But what we're going to be doing is we're going to be creating a new admin account, a new user account with a different username, and I'm going to be calling this Retrospector78. So I'm going to be giving it a strong password as well. If you have a password manager like 1Password, I highly recommend you storing your password in those as well. And then it's just a matter of putting it in the administrators group, which should give it full administrative access to the system. So now we both have an admin user and a Retrospector78 user. Now, obviously, I am still logged in as the admin user. I cannot disable the admin user now. So what I can do is I can log out and then log in again using the Retrospector78 admin account. And from there on, I can just go ahead and disable the default admin user account. And these little things just make the whole, the overall system a whole lot more secure. But now on to some more fun retro stuff, as we're going to be doing some networking on MS-DOS 6.2. Now I am going to be starting off by installing MS-DOS in a VirtualBox, which makes it very easy to test and try things out within the comfort of your standard workstation. You don't need to rely on an actual retro machine at first. You can basically try everything out in VirtualBox, which I'm going to be doing here. So I have MS-DOS 6.22 installed, which obviously doesn't have any networking capabilities, but for that we're going to be installing Microsoft Network Client version 3.0, which is a 2-disk setup. We're going to be installing it in the net folder on our C drive. It's going to be examining our system. It hasn't found any networking card, so it will prompt us to either select a networking card or provide us with a custom disk which contains a network card driver. This is something that we're going to be doing because VirtualBox has excellent networking support, and there is an NDIS2 driver available for MS-DOS for the emulated networking card in VirtualBox. So we'll insert the disk, and it has found our advanced micro devices PCNet family networking card. We'll go ahead and select that. And after entering a username, which is something which is required for MS-DOS networks, as you always need to log in with a username into a network, we can go ahead with our configuration. So let's take a look at the options that we have here. If we go into the network configuration, we see our networking device. We see an IPX protocol, which we're going to be changing. We're going to be removing it, in fact, because we only need TCP/IP. So we're going to be removing the IPX compatible protocol, and we're going to be replacing it with Microsoft TCP/IP. Now the default settings will suffice for now because it will be used DHCP, so it will get an IP address from a DHCP server, which is what we want. And we should be good to go pretty much with this setup. So we can continue with the installation, and then it will ask us for a reboot, and hopefully then our networking stack will be started, and we'll see where we go from there. So let's perform the restart. We're starting MS-DOS, and as we can see, it has picked up our AMD PCNet family Ethernet adapter. It will prompt us for a username, so we're going to be using user1. We need to type in a password. It's the first time we're logging in as this user, so we're going to be saving the password. So we need to confirm the password. It will then write that password into a file. And from now on, we're basically logged into the Microsoft network on MS-DOS. Now, to make sure that we have network connectivity, we can verify it with the ping command, as we have installed TCP/IP. So it's just a matter of trying out an IP address. I'm just going to be using the one from my router, and as you can see, it has received a reply. Now, the concept of having a user that you use to log on to the network and providing a password is very important here, because this is something that we do in MS-DOS. For example, here I'm logging in as user1. What you typically see in Windows environments, you get this network login prompt, meaning that you need to provide credentials for a particular user. And that also means that on the NAS device, we need to have that same user present here with the same password, because we need to provide valid credentials in order to access our shares. Now, there is a way to fall back to a guest account if the guest account is enabled on the NAS device, which by default it is not. But now let's go back to our first virtual machine with MS-DOS 6.22, as it is booting here and it is initializing TCP/IP. So we're logging in as user1, we enter our password, and now let's see if we can access our network here. And within MS-DOS, we typically use the net command to browse our network, as there is no graphical user interface here. So we can do a net view to see if we can find any devices on the network. For the moment, there isn't a list of servers in the workgroup available. So let's see if we can target our AsusStor directly using its name. And what we're getting is error 58. The network has responded incorrectly. Now, if I do the same net view with a non-existing name, I get a different error, meaning that somehow using the AsusStor name, it has found something, but it's not responding accordingly. So what's going on? Now, in order to find that out, we need to log into our AsusStor using SSH and go into this folder here. And what we have in this folder is our samba.log file, which is basically the log file for the SMB service running on the NAS. And what I'm going to do is I'm going to put a tail on the log file here, and then I'm going to be executing some commands from my msdos workstation here and see what kind of logging we can get. So let's do the net view again. And let's return to our log file here, and that has dumped a lot of information here in this log file. But if you know what to look for, we can find out what went wrong. So if I'm looking for protocol, for example, we can see that a client has requested a number of protocols here to connect to the NAS. And ultimately, our NAS has decided that it is not accepting any of these protocols, because if we look further down, we see that during the negotiation of the protocol, the NAS device has said no protocol supported, and it has basically rejected the request from the MS-DOS machine. It did a server exit, and that's why we're seeing that error message here, error 58, the network has responded incorrectly. Now, why is that? Now, in order to understand that, we need to dive into some theory. So I've created this little slide deck here about the SMB protocol, where I would like to cover a couple of things. So I would like to cover the SMB architecture on a very high level, the different SMB protocol versions, the connection protocols and the connection protocol negotiation process, SMB authentication, and guest-based access. Now, first, on an architectural level, what we have basically is we have a client-server network where clients can be MS-DOS machines, Windows 3.11, Microsoft Windows 95, 98, all flavors of Windows, but even Linux and Mac machines can act as a client. On the other hand, we have some servers, typically Windows NT, Windows 2000, and so think of these servers as machines which are offering file shares that you can connect to. But these quote-unquote servers can also be standard Windows 95 machines. They can be Linux machines, and your NAS device is also a server in that regard, running a piece of software called Samba. And in between we have SMB, or the Server Message Block Protocol, a well-established and well-supported protocol allowing clients and servers to exchange information. Now, there are three major versions of the SMB protocol. We have SMB1, SMB2, and SMB3. Now, when it comes to retro computing, we typically use operating systems like MS-DOS, Windows for Workgroups, Windows 95, 98, or XP. And these types of operating systems can only work with SMB1. So SMB2 and SMB3 are already out of the picture. Now, SMB1 was created by IBM in the 1980s, and then Microsoft took over in the early 1990s. They made their own flavor of the SMB protocol, and it was heavily used for MS-DOS, Windows for Workgroups, Windows 95, 98, and XP. Now, the protocol itself was very inefficient and insecure, so there were subsequent releases to the SMB protocol in 2006 and 2012. But because we're talking about, Vista and upwards, we're not going to be focusing on that. The focus of this video is going to be SMB1. And primarily how we can get our NAS device to work with SMB1, and in particular have it working with MS-DOS and Microsoft Windows for Workgroups. So now that we know a little bit about SMB, let's talk about the connection process. And there's basically three steps involved. First is the protocol negotiation. The client and the server need to agree what protocol they were going to use in order to connect with each other. Once the protocol has been established, we need to log on to the server. So the client needs to provide credentials to the server in order to log in. And once authentication has been established, the client can connect to various shares on the servers or printers and exchange information. So yeah, remember when we had this issue and we looked at the log file and we saw that our MS-DOS machine was unable to connect, and we noticed this no protocol supported message during the negotiation protocol? Well, now we know that something went wrong in step 1. Now, within the SMB version 1 of the protocol, there are many different dialects, and we need to ensure that our SMB server or our NAS device is in fact supporting a particular dialect, because obviously for security reasons, NAS devices or SMB servers will drop support for certain protocols or certain dialects because there might be security implications. And sure enough, when we go to the services of our AsusStor NAS device, go into the SMB service, we see that there are a couple of settings related to the lowest SMB version that our NAS device supports, which is default SMB2. Now that's already a reason why MS-DOS cannot connect, because MS-DOS will only support SMB1. So let's switch it to SMB1 and let's do the same test again. So let's execute our netview command again, look at the log files, and what we're seeing is exactly the same thing. The client is requesting different protocol support, and the server basically responds with no protocol supported, despite the fact that we selected SMB1. So what gives? Now, in order to investigate, we need to look at our samba.conf file, which is basically the underlying configuration file for the SMB service. Now, this configuration file, located in the volume 0 user built-in etc samba folder and called smb.conf, basically contains the underlying configuration properties that can be manipulated using the AsusStor ADM web UI. And as you can see, the minimum protocol by default is SMB2. When we change it in the UI to SMB1 and we look again at the smb.conf configuration file, what we will see is that the server minimum protocol is now set to something called NT1. Now, NT1 basically is Samba version 1, and more specifically, it's the most current up-to-date version of the SMB1 protocol. Only problem is it's used by Windows NT and upwards, meaning you have Windows NT, Windows 95, Windows 98, which is compatible with NT1, but older clients like MS-DOS and Windows for Workgroups are not. So that poses a problem, because this is the lowest setting that we can set using the web interface. So the only thing we can do now is to change it manually in the file itself and switch the minimum protocol to LAN-MAN1. So what is LAN-MAN1, you might ask? Well, it's the first modern version of the SMB1 protocol with long file name support. And it just so happens to be the version of the protocol which is supported by MS-DOS and Windows for Workgroups. Now, the problem with this approach is that although we can change it in the file here, it is not going to be persisted, because every time we make changes in this UI, our file will get overwritten again. And because there is no drop-down option for LAN-MAN1, the server minimum protocol will always be set to either NT1 or SMB2. So that's an issue. Now, because we need to restart our SMB service every time we change the config file, changing this minimum protocol to LAN-MAN1 means that we need to restart the SMB service. Now, normally this is done through the UI, but for obvious reasons, we cannot do that now. So I'm going to stop and start the SMB daemon on the NAS using this command here. And so by launching this initd script, by stopping and starting the SMB service, we can effectively maintain our minimum protocol to LAN-MAN1. So let's switch back to our MS-DOS machine and execute the netview command again. We get a different error this time. So we no longer get the error the network has responded incorrectly, but we get an access denied. And if we look at the log files and we look at the protocol matching, we can see that now the NAS device has selected a protocol from our DOS client, the LM1.2x002, which is an old LAN-MAN protocol. But then why are we getting that access denied error? Well, remember how the SMB connection process involves 3 steps. We have the protocol negotiation, which has been successful, but then we have the server login, meaning we need to authenticate to the server. And apparently that's where we have an issue at the moment. Because if we scroll down the log file, we see the following error message. LAN-MAN passwords are not permitted for user 1. So the LM password and LMv2 failed for user 1, and the NTMD4 password in LM field not permitted. Now, why is that, and what does this even mean? Well, in order to understand this, we need to understand that we are now stuck at step 2, the server logon. So we are not able to authenticate to the server from our MS-DOS client. Now, the reason is that Within the SMB version 1 protocol, there are basically 3 ways you can authenticate as a user. We have LAN-man authentication, NTLM authentication, and NTLM v2 authentication. Now, LAN-man authentication is the oldest way of authenticating a user to a Microsoft SMB network. It's part of Microsoft LAN Manager or Network Client, the client we happen to have been installing in MS-DOS and Windows 3.11, and it is considered very insecure. On modern hardware, it's basically a matter of seconds to brute force attack a encrypted password using LAN-man. Now, unfortunately for us, MS-DOS and Windows 3.11 only support LAN-man, so we need to somehow configure our NAS box to support this LAN-man authentication. So with this understanding, it becomes clear that, okay, LAN-man passwords are not permitted for user 1. So this basically means that the NAS device has detected that the client is trying to send a LAN-man password, but the server is no longer accepting LAN-man passwords, and it ultimately fails by saying that LM password and LMv2 failed for user 1, and that refers to NTLM and NTLM v2, which is not supported by MS-DOS. Now, spoiler alert, the NAS device does allow us to have support for both NTLM and NTLM v2. If we have the checkbox enable only NTLM v2 authentication, we're basically forcing the client to use NTLM v2. That's what the NTLM auth is no means. NTLM auth is no means that we only support NTLM v2. Now we can fall back to NTLM and not NTLM v2 by unchecking this, and what will happen in the config is that NTLM auth will now be set to yes, meaning that NTLM version 1 will be supported. Keep in mind that the minimum protocol is again set to NT1 because we made a change in the UI. So we need to set this back to LAN-man 1, but this will not help in MS-DOS because NTLM is also not supported in MS-DOS. And we need to get LAN-man support in our NAS device, and the only way to do that is to enter the smb.conf and add the entry LAN-man auth equals yes. So this little line here will add LAN-man support to our NAS, and the NAS will be able to accept the LAN-man password sent by our MS-DOS client. So let's take a look. Okay, so in theory, everything should work now, right? We do the net view and we should get our drives. But no, we get an access denied, but only this time we get a different error in the log file. We see that there is no LAN-man password set for user 1 on the NAS device. Now, why is that? Well, that's because we have never configured the NAS device to support LAN-man passwords. And if you have a user on the NAS device that was created before there was LAN-man 1 support on the NAS, there would never have been a LAN-man password set for that user. So now that we have LAN-man support on the NAS device, if I just update my user 1 here, what will happen is that the NAS device will now set a LAN-man password for user 1, providing that the password was less than 14 characters, and we will have LAN-man support. Because here, Eureka, we see all of the shares on our AsusStor. Now let's look at the log files to see what happened. And indeed, we're seeing that LM password check, and the password check was successful because the NAS device has allowed our user to log in, and we can now see the shares. We can map the shares to drive letters in MS-DOS. For example, I'm going to add the H drive and map it to my home folder. And now I have this cozy little H drive letter here that I can use as my own personal space. So let's recap what happened here. We started off with the minimum protocol SMB2, and there was no protocol support from MS-DOS. Makes sense. We then switched the minimum protocol to NT1 with the same result, no protocol supported from MS-DOS. It's only when we switched to LAN-man 1 as the minimum protocol that we were able to connect with our MS-DOS client. Now keep in mind that LAN-man 1 is not something you can select from the user interface, and it only covers the protocol negotiation. After that, we ran into authentication issues. And that's because with NTLM v2 only authentication, meaning NTLM auth is no, MS-DOS could not authenticate. With NTLM auth equals yes, meaning that we allow NTLM v1 authentication, it was still not sufficient because MS-DOS only supports LAN-man authentication. Now, it was at this point that most sane people would have quitted because we were still getting issues even with LAN-man auth equals yes, and that's because there was no LAN-man password set. But when we updated the user with the user interface, we were able to log in because a LAN-man password was set by the NAS device and it got accepted by the NAS server when the MS-DOS client tried to connect. So yeah, finally, after many hours of trial and error and debugging, we finally get to access our NAS device from MS-DOS, and we can start interacting with it. In MS-DOS, this is primarily done using the net command, which brings up this kind of user interface, allowing you to browse the network, to connect to the network, but we can also do everything command line. There are lots of parameters that we can use on the net command. We can use it to configure the network, diagnose the network, do log on, log off. Now, when you launch the net command, you get this interface, which allows you to browse the network. As we can see, we have our AsusStor here. We have our shared directories. We can map it to a drive letter. We can configure it to reconnect at startup, which is a handy feature, meaning that if we restart our computer, the next time we log on to the network, we will be able to get the drive mapped automatically. And one final thing that I would like to cover is the map to guest functionality. Now, this is something that most SMB servers support, and it dictates the way how the system should behave when a user is either unknown to the NAS server or it provides wrong credentials. Now, by default, the map to guest feature is set to never. That basically means that you need to be authenticated in order you can get access to the NAS device. If you provide invalid credentials or you log in with an unknown user, you will be denied access. Now, this is the default behavior on the AsusStor, providing your guest account has been set inactive. So as soon as you activate your guest account, you will fall into the bad user map to guest option. And that means that when you have a user which logs in with an invalid password, or you try to log in with a user which is not known to the NAS device, you will get access to the NAS device as the guest user. So it's kind of a fallback. So yeah, in this video, we've covered a lot of stuff. We finally got our MS-DOS virtual machine up and running on the AsusStor. Unfortunately, I ran out of time with this one, so I wasn't able to get it up and running in time on this actual compact 486 computer, so that's going to be for a next video. Luckily, we've prepared everything in VirtualBox, so I'm pretty confident that we will get this up and running on the actual computer. But so that's going to be for a next video. In the meantime, I really hope you've enjoyed this one and look forward to seeing you in the next one. Bye-bye.